All right, so here we go. 6.6, solving rational equations. So I always like to try to give you the big picture, like what's the overview of what you're trying to do. So the big goal when you solve rational equations is that you need to move all x's out of the denominator. We cannot solve with any of the techniques you've learned. Factoring, quadratic formula, regular linear solving. You can't do any of that if you have x's in the bottom of the fractions. So your main goal behind the process today is to get all the x's out of the bottom and then solve. So that's really most of the process. All right, so Roman numeral 1, let's go through the steps. And a lot of these steps are going to look familiar because they're the same ones that you do for adding and subtracting fractions. So step 1 is you're going to factor all denominators. And I'm just going to abbreviate that denoms. Factor all the denominators. And we've been practicing that. Okay, step 2, you're going to make a lowest common denominator. And the abbreviation for that is LCD, lowest common denominator. And you do this by multiplying. So you're going to multiply by a missing factor over itself. Multiplied by a missing factor over itself. Again, we've been doing that. When you add fractions, that's how you get the bottoms to match. You multiply by what it's missing over itself. The only difference in this is it's going to be across an equal sign, left and right. And again, really, really important is you need to do the lowest common denominator. If you don't, the result isn't solvable. So you want to go for the lowest possible denominator. Okay, so we factored all the denominators. We got a lowest common denominator. Here's a step that we don't do when we add or subtract fractions. We're going to eliminate the denominators. Because we don't want x's in the denominator, we can't solve with them there. So we're going to move them out. And you accomplish this by multiplying both sides of the equal sign by the lowest common denominator over 1. And that will eliminate them. Once you've got all the x's out of the bottom, now you're going to use your mental library to solve for x. And these are going to take many different forms. One of the forms they're going to take is just basic linear solving. And a lot of your homework tonight is going to be basic linear solving. That's something like 3x plus 2 equals 6, where you add or subtract x's left, numbers right. You know, this is your Algebra 1 solving. But you can spot linear solving because all of the x's will be to the power of 1. If they are single x's like that, then it's linear solving. If you have an x squared or an x cubed or anything higher than that, you're going to factor to solve. So that's where you end up with something like x times x plus 2 equals 0, and you end up with multiple answers, in this case 0 and -2. So if you have a higher order of x, that's how you're going to do it. You're going to factor to solve and make sure you make it equal to 0, zero product property, and then you solve. And we've been practicing that, just not all together. So sometimes it's going to have an x squared in it, and it's not factorable. You tried to factor it, it won't factor. In that case, you're going to need to use the quadratic formula. And since it was not factorable, your answers are going to be like A plus or minus radical B. They might have an imaginary unit on it. There's a lot of different possibilities for that. But if it's not factorable, it means your answers are not going to be whole numbers or fractions. If you do get whole numbers or fractions from quadratic formula, it meant that it was factorable and you did it the slowest way possible. Okay, so that is the basics. All right, we're going to now get to the practice. So example 1. We're going to start easy and then go a little bit more challenging. We're going to solve 3 over x squared plus 4x equals 1 over x plus 4. All right, so the very first step in the process is factor the bottoms. This is a binomial, and I can divide an x out. So that gives me 3 over x times x plus 4. And on the 1, x plus 4 is as factored as it gets. You can just put it in parentheses because that's done. All right, so that's your first step, factor all the denominators. Okay, step 2, make a lowest common denominator by multiplying by the missing factor over itself. This one is missing a monomial x. So we're going to multiply by x over x. So now I've got 3 over x times x plus 4 equals x over x times x plus 4. All right, this is where we're ready now for step 3, which is to eliminate. So because it has an equal sign, this next move is legal. It's not legal for adding and subtracting because there's no equal sign. And you can do anything equally to both sides of an equation. That's one of our algebra rules. So what I'm going to do is I'm going to multiply the right by x times x plus 4 over 1. And I'm going to multiply the left by the same thing, x times x plus 4 over the 1. So because the denominators match each other, that's why when we multiply both sides by the same thing, everything cancels out. And all you have left is what's on top. In this case, 3 equals x, which is x equals 3. So we get a common denominator specifically for this elimination step. They have to match to eliminate them. All right, so that's our first example, kind of an easy one. All right, now we're going to go to one that's a little more complicated. This is example 2. We have 3x minus 2 over x minus 2 equals 6 over x squared minus 4 plus a 1. All right, so your very first step, factor the denominators. So in the case of the x minus 2, it's as factored as it gets. So x minus 2, just put it in parentheses, equals 6 over. Now, x squared minus 4 is the difference of 2 squares. So x plus 2 times x minus 2, and that one's factored. Now, the 1 has nothing under it but a placeholder 1, and that's factored. Okay, so that's step 1. We have factored everything. Now we're going to get a common denominator. So we're going to multiply by what it's missing over itself. This left one is missing an x plus 2. So I'm going to multiply by x plus 2 over x plus 2. The middle one already has an x plus 2 and an x minus 2, so it's done. The right one has nothing, so it needs everything. So we're going to multiply by x plus 2, x minus 2 on the bottom, and x plus 2, x minus 2 on the top. All right, so normally I wouldn't write this next step out, but this is notes, and I want you to see really clearly where things go. So we're going to write out what we've got. We have x plus 2 times 3x minus 2 over x plus 2, x minus 2 equals 6 over x plus 2, x minus 2 plus x plus 2x minus 2 over x plus 2x minus 2. So now we have a common denominator for all three terms. So this is the elimination step. We're going to multiply by x plus 2, x minus 2 over 1 on both sides. And again, this next step I write out just on the notes. I do have people that write it out on their work because they'd say they just can't make sense of what gets crossed out without it. So on this side, the tops and the tops get multiplied. So you have the x plus 2, x minus 2, and then you have the x plus 2, 3x minus 2, which was already there, over x plus 2, x minus 2. Tops and tops. On the right, there was more than one term. So when you multiplied by the LCD over 1, it gets used twice. So I have a 6 times x plus 2, x minus 2 over its denominator, x plus 2, x minus 2, plus I have an x plus 2, x minus 2 times the blue one, x plus 2, x minus 2, all over x plus 2, x minus 2. I find if people are crossing out the wrong things, this is the step they need to show so their brain can see why they're crossing stuff out. Most of you won't need to show this step, which is fine. So as you can see, we multiplied by the LCD over 1. It's now in all of the terms. Over here it got distributed, so it's used twice. Here it didn't, it's used once. This is why it works. Because x plus 2 on the top, x plus 2 on the bottom, x minus 2 on the top, x minus 2 on the bottom. For the 6, the x plus 2's divide out, the x minus 2's divide out. And for the last one, the x plus 2's divide out, the x minus 2's divide out. So now all we have left is x plus 2 times 3x minus 2 equals 6 plus x plus 2, x minus 2. And if you look backwards, in the step where you got the common denominator, this is everything on the top. Only the bottoms got canceled out. And that's why it works. When you've got a common denominator and you multiply by that denominator over 1 on both sides, all of the denominators cancel out. Okay, so now we're going to simplify. X times 3x is 3x squared. X times negative 2 is negative 2x. 2 times 3 is 6x. 2 times negative 2 is negative 4. On the right, I have a 6 plus x times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. 2 times negative 2 is negative 4. We can tell that we have x squareds, which means we're going to use zero product property, which requires everything to be equal to 0. So because I have x squareds, this is a factor to solve style of question. So let's simplify and then we'll move. So on the left, you have a 3x squared. 6 minus 2 is 4x minus 4. On the right, you have an x squared. The single x's add up to 0. 6 minus 4 is 2. So I just simplified both sides. Now we're going to do zero product property equal to 0. So I'm going to subtract x squared over to the left, and I'm going to subtract 2 over to the left. That gives me 2x squared plus 4x minus 6 equals 0. So now we're going to factor. I can divide a 2 out of those. So x squared plus 2x minus 3. And the trinomial that's left, regular ABC factoring, x plus 3x minus 1 equals 0. And we solve each piece. So set 2 equal to 0, set x plus 3 equal to 0, set x minus 1 equal to 0. This is zero product property. Now, obviously, 2 does not equal 0, so that one did not give us a solution, but the other two do. If I subtract 3, x is negative 3. If I add 1, x is 1. So my x's are negative 3 and 1. Remember that when you have an x squared to the power of 2, that indicates you should get 2 answers. They might be the same answer twice, but you should still get 2 answers if it's an x squared. All right. We're going to do one last one because there's one piece of the notes we haven't covered yet, and that is extraneous solutions. So I found a pretty short example to show you what that looks like. The harder the problems are, the more extraneous answers there generally are. So we're going to solve 1 over x minus 5 plus x over x minus 2 equals 3 over x minus 2, x minus 5. I'm just going to factor that one right away. Okay, so the actual solving process is going to be the same. So we need a common denominator, and everything is pretty much already factored. So for the 1, I need an x minus 2. So I'm going to multiply by x minus 2 over x minus 2. For the second term, I have an x minus 2. I need an x minus 5. So multiply top and bottom by x minus 5. And the last one already has an x minus 2 and an x minus 5, so it's done. Okay, so just to make room here, I have an x minus 2 over x minus 2, x minus 5, plus, and I'm going to go ahead and distribute that x squared minus 5x over x minus 2, x minus 5 equals 3 over x minus 2, x minus 5. So we have a common denominator. And then here's the shortcut. Feel free to use it. We need to multiply every term on both sides by the lowest common denominator over 1. So we're going to multiply by x minus 2, x minus 5 over 1. This will cancel out all of the denominators. So now all we have is the tops, which was x minus 2 plus x squared minus 5x equals 3. Now, because we have an x squared, this is zero product property, so we need it equal to 0, and then we're going to need to factor it. So I'm going to move everything to the left and simplify. So I have an x squared. X minus 5x is negative 4x. I'm going to subtract 3, and that gives me a negative 5 equals 0. Now we can factor. X minus 5 times x plus 1 equals 0. Set each factor equal to 0. So x minus 5 equal to 0, x plus 1 equal to 0, and solve. We get x equals 5 and x equals negative 1. Okay, here is where you have to check for extraneous solutions. In particular, when you get more than one answer, there's a higher likelihood that one is extraneous than when you get one answer, but you always want to check. So in this context, an extraneous solution creates a 0 in the denominator of a fraction. And you're going to want to look at the factored form, not the original form. So, and the reason it's extraneous is you can't divide by 0. Like 2 divided by 0 is undefined. You can't divide by 0. So if one of your solutions creates a 0, then you have a problem. So just rewriting the original when it in factored form, it was 1 over x minus 5 plus x over x minus 2 equals 3 over x minus 2x minus 5. So if you look at the 5, if you substitute it in there, I get a 1 over 5 minus 5, which is a 1 over 0. We cannot divide by 0. So that means x equals 5 is extraneous, and you need to list it as extraneous. Now, my other answer, -1, won't create a 0 at any place, so that's still a solution. So this only had one solution. It was -1 and not 5. Can someone look at that equation and tell me what other value of x would have been extraneous? 2. Yeah, if x was 2, 2 minus 2 is 0. So you can kind of look ahead sometimes and go, oh, look, x can't be 5, x can't be 2. Just to make sure that you're aware of it, and then finish the problem and see, did I get a 5 or a 2 if I did their extraneous? Now, let's say that all your answers are extraneous. Okay, if all answers are extraneous, then there is no solution, and that would be your answer. Along with listing the extraneous values, your problem would be no solution.